The first part of the second video here is about adding and subtracting polynomials. On your next worksheet, problem set 6.2, you're going to have a bunch of questions about adding, subtracting, and multiplying polynomials, because polynomials can be combined in the same ways that any other thing can be combined. Adding, subtracting numbers or fractions. I mean, it's different rules and different things you need to be careful about, but ultimately it's the same idea. And you've already talked about probably how to do this in class, but what it comes right down to is combining like terms. But being careful with your negative signs as well. I'll give you an example. X to the third y plus 3x squared y squared minus 7xy cubed minus 7y cubed x plus 4x cubed y minus 3x squared y squared. This will be the polynomials that we're going to subtract from each other. Keep in mind also, when you're given the polynomials in kind of a verbal form as opposed to actually written out like this, pay attention to words like subtracted from or less than. Because remember, if you say something like x less than 5, remember that that doesn't mean x minus 5. No, it means 5 minus x. The less than means you need to switch the order. So if you see something like x squared plus 9 less than 5x plus 2, you need to switch the order. If you see x squared plus 9 subtracted from 5x plus 2, you need to switch the order. So pay attention to that sort of thing. But once you have your polynomials set up, and you can set them up vertically like this or horizontally, it doesn't really matter how you approach it. The first thing you need to make sure that you do is, especially for subtraction problems, make sure that your signs are all appropriately determined. The signs of each individual term, I mean. This is a subtraction. We're subtracting the whole polynomial. So for subtraction, what I recommend that you do is change it to addition, but then distribute the negative all the way through the polynomial. Distribute the -1. Pretend that that minus sign was actually a -1 and distribute the negative sign all the way through. Because I can't tell you how many times I'll see somebody take something like x squared plus 1 minus 5x squared minus 3, for example. And they'll do x squared minus 5x squared, so they'll get negative 4x squared. But then they'll do 1 minus 3 and get -2. But that's wrong, because it's 1 minus -3. If you change that to a plus, you'll know that that's supposed to be plus 4. So change the negative sign. Distribute the negative sign all the way through. The second thing to watch out for is to make sure that your like terms are lined up. If they're vertically, rearrange the terms so that your like terms are together. If it's horizontal, I recommend maybe putting a circle around some like terms and a square around other like terms and a triangle around other like terms, so that you know what terms are corresponding to which other terms, which terms you can combine, essentially. But writing vertically like this makes it really convenient because you can just line them up. One thing to be careful about, though, is the order of the terms. X cubed y, y cubed x, those are not like terms. But y cubed x could be written as xy cubed, which would make this term comparable to that one. So we could rearrange these, but I want to show you what I mean by like circling and things. So I'm going to circle the negative 7xy cubed and the negative 7xy cubed to show that those are the two things that I'm going to be combining. Another pair of terms that I can combine are the 3x squared y squared and the 3x squared y squared. So I'm going to put a box around those. This works really well if you have multiple colors as well. Use different symbols to make it easier for you to see where things are, but use colors too could help. And then same idea, x cubed y, those are like terms. I'll put a triangle around them to know that I'm going to be combining them. It may happen that in your polynomials there's some terms that don't match up with anything, and so they won't be touched. Maybe the negative sign will change the value, change it from positive to negative or from negative to positive. But if there's nothing to combine it with, it's not going to change. So now I'm going to combine my like terms. I'll combine the circles first. I have negative 7xy cubed plus negative 7xy cubed. Well, that's negative 14xy cubed. Remember that the exponents don't change. When you're combining like terms, something like 5x plus 3x, that's 8x, not 8x squared. 8x squared means you're multiplying x times x. We're not multiplying the x's. We're adding them. We're adding these terms. So this does not, the powers don't change. The powers don't change when you're adding or subtracting. So we get negative 14xy cubed there. And then we have 3x squared y squared plus 3x squared y squared. So that's 6x squared y squared. And then we have x cubed y minus 4x cubed y. So that's negative or minus 3x cubed y. The last step you want to, when you're combining like terms like this, when you're adding or subtracting like terms, is to put it in what's called standard polynomial form. And you might have talked about it in class, but what it really means is look at the powers and write them in order of what the powers look like. And you'll notice that we have x to the 1, y to the 3, so that's kind of an overall power of 4. We have a power of 4 here, we have a power of 4 here, so it's debatable which of these really should come first. But if you have things like x squared, like 3x squared plus 4x plus 1, writing them in descending order like this, because remember, we could write that as x to the 0 and that is x to the 1. This is called standard polynomial form. This is the kind of ideal way of writing the polynomial. It's not a requirement. You don't have to write it like this because addition is commutative. It doesn't actually matter what order you write them in. But it's good form. This, writing this in a different order, like 4x plus 1 plus 3x squared, it's not any less meaningful. It's not incorrect. It just looks weird to a math person like me. I'm going to look at this and it just makes me, I don't like how it looks, that's all. There's nothing mathematically incorrect about it, it just looks funny. So if it's obvious and if it's easy to figure out what order to put the terms into, put them into standard polynomial form, but when they're kind of complicated like this, whatever form you give the answer in really doesn't matter.